Okay, now what is gravitational field strength? Gravitational field strength has another name called acceleration due to gravity. So these two, they are the same. Gravitational field strength sometimes can be called gravitational field strength, or sometimes we call it acceleration due to gravity. And both of them are the same. Sometimes we even say that gravitational field strength, we just say it is this one, yeah? Sometimes we even call it gravitational field density or gravitational field intensity. So they actually have several names: gravitational field strength, acceleration due to gravity, gravitational field density, or gravitational field intensity. Okay, all of them mean the same thing, which is Ag. The symbol for gravitational field strength is Ag. Okay. So okay, if you look at this one is I'm sure last time you learned about this formula. Okay, you learn gravitational force. Gravitational force is actually the weight of object, isn't it? A weight of object, which is mg, isn't it? So now we don't write as W equal to mg, because that one is only for on surface of Earth. This one is only for on the surface of Earth. When near to Earth's surface, we use, instead of W, we use Fg. And then mass still the same, and instead of gravitational field strength, we use Ag, also gravitational field strength. Okay, but the thing is, why now we change a bit the formula? Because the gravitational field strength is not the same, yeah. It's not the same when you go away from the Earth. Okay, only on the surface of Earth, when the distance to the center of Earth is radius of Earth. Okay, what I can say is okay, hold on a second. Yeah, so on the surface of Earth, the gravitational field strength is value G, which is 9.81. So when near the Earth's surface, the gravitational field strength is the gravitational field strength is 9.81. But when you go away and away from the Earth, the gravitational field strength become lower value. Yeah. When away, when far from Earth, we use this formula, Fg equal to mag. Okay, where this value will be less than or equal to 9.81. 9.81 is actually the maximum value. Yeah, on the surface of Earth, actually the gravitational field strength is at maximum. But when you're going away from the Earth, the field strength become weaker and weaker, become less than 9.81. Okay, so from here, from this formula, later we can derive it. We can get a formula for gravitational field strength, Ag. Okay, by using Fg divided by the test mass. Okay, divided by the mass. So that's why we have this formula, Ag equal to Fg over m, which is this one. Okay, so this one is actually the definition. Actually this formula is this is the definition of Ag. This is actually the definition of the meaning of gravitational field strength. Okay, let us look at the definition of gravitational field strength. Gravitational field, is defined as the gravitational force, okay, which is this gravitational force is Fg. Okay, gravitational force is Fg per unit mass, of body. So this is the m, small m, okay, of a body, which is the test mass placed at a point. Okay, so what I can say is gravitational field strength is actually also gravitational force, but per unit test mass, per 1 kilogram. What does it mean? What is actually means by this formula? Let's say I have gravitational field strength. Let's say this is the Earth. The Earth. So this Earth provide the gravitational field. So there is field is like an area. You understand? Field is like an area. An area that you can feel the gravitational force. Yeah. An area that you can feel the gravitational force. Okay, so this area, okay, okay, now let's say at this point, it has gravitational field strength of, I put it at gravitational field strength of how much? Let me see. Let's say it has gravitational field strength of 10. Okay, 10 Newton per kilogram. That is actually the unit for Newton per kilogram is actually the unit for gravitational field strength. Because we look at this formula, force over mass. Force over mass, the force is actually Newton, the mass is actually kilogram. So that's why the unit for gravitational field strength is Newton per kilogram. Okay, or meter per second square. We will look at this later on. Okay, so this is the unit for gravitational field strength, Newton per kilogram. So what is actually mean by gravitational field strength 10 Newton per kilogram? Let's say at this point, we put it as point P. Okay, so let's say the gravitational field strength, the gravitational field strength at point P is 10 Newton per kilogram. What is actually mean by this statement? What do you understand by this statement? So this statement means, it means if we make into a fraction, okay, force per unit mass, it actually means 10 Newton per 1 kilogram. So that means if I have the top here is the gravitational force, bottom here is the test mass. We call it the test mass. So that means if I have a 1 kilogram test mass over here, if I place a 1 kilogram over here, okay, at this point P, okay, I just want to rub this off. Okay, let's say I have 1 kilogram test mass over here. Okay, let's say I have a 1 kilogram test mass over there. So this 1 kilogram will experience 10 Newton attractive force to the Earth. It will experience this this blue line. Okay, you experience the attractive force. You experience the attractive force of how should I draw it? Yeah, you experience the attractive force. You experience attractive force of 10 Newton attractive force to the Earth. That is what it means by 10 Newton per kilogram, the gravitational field strength over there. Okay, so if that point, he says that the gravitational field strength at that point is 10 Newton per kilogram, that means if I put a 1 kilogram mass there, it will experience a gravitational force of 10 Newton it will experience an attractive force of 10 newtons towards the Earth. Okay, so this gravitational field is actually an area that you experience this kind of gravitational force. Okay, you place the mass no matter where around the gravitational field, you will surely feel this gravitational force. Okay, gravitational force. If you are nearer to the Earth, of course you feel a stronger force, but if going away from the Earth, you feel a lesser force. Okay, that is what it means. So, okay, gravitational field strength is like 10 Newton per kilogram. It is defined as the gravitational force 10 Newton per unit mass. Per unit mass means per 1 kilogram. Per unit mass means per 1 kilogram of body of test mass placed at a point. That means if I place 1 kilogram at that point, it will experience 10 Newton attractive force to the Earth. Okay? So that's why gravitational field strength is also a vector. Why is it a vector? Because gravitational field strength is actually gravitational force per 1 kilogram. Okay, you see, gravitational field strength is actually the 10 Newton force for 1 kilogram. Okay, gravitational field strength is also a force. So since force is a vector, you see, force is a vector, that's why gravitational field strength is also a vector. Okay. That means it has direction towards the center of the Earth. Okay. So alright, that's the meaning. So this below here, this is the test mass. Okay, test mass. And okay, just now the formula for Fg. Is gmm over r square. So we put into the formula of gravitational field strength, Ag, what will happen? Okay, this formula, okay, Fg divided by the test mass. So that means the test mass is being cancelled off. You see that? It's being cancelled off. So what's left is only the gm over r square. So this is the final formula for gravitational field strength, which is equal to gm over r squared. This m is the point mass. It's a point mass. What is meant by point mass? Point mass means he is the one who the provider of field. Understand or not? Point mass is the provider of field. It provides this gravitational field. Without this point mass, without the Earth, there's no gravitational field for the gravitational force to exist. Okay, so point mass is the provider of the field, whereas the test mass is the one who experiences the field. The test mass, yeah. Hold on a second. Just want to drag this on top a bit. Okay. Whereas I want to say this one. Test mass is the one who experiences the field. Inside the field. Or we can say as okay. Test mass is the one who experiences or inside the field. It's not the provider. So that means if without the test mass, the gravitational field still exists. Even though like this 1 kilogram, is the test mass. Okay. If let's say the 1 kilogram is not there, but the point mass is this is the point mass. Understand? And the 1 kilogram is the test mass. So if let's say this test mass is not there, but even though the test mass is not there, so the gravitational field still exists because the point mass is still there. Okay? If the test mass is not there, the gravitational field still exists because the point mass is still there to provide the field. Okay? So remember, the big M here is the point mass or the provider of field. So the bigger the provider of field, the bigger the point mass, the stronger the gravitational field strength. Okay, so that means the bigger the Earth here, then the stronger the gravitational field it provides to the surrounding. Understand? Okay. One more thing about this R. R is actually the distance from the center of the provider. Okay, center to the provider of the field. So this R is, if you look at here, this R is radius of Earth plus altitude. H is the height from surface, or we call it altitude. So R is actually radius of Earth plus H. You see that? Radius of Earth means the radius of Earth, the radius of Earth, and H is the height from the surface of Earth, the height. Sometimes you call it height, sometimes you call it altitude. So to get the R below here, you must take radius of Earth plus altitude plus the height. Don't ever just take the height. Don't ever just, many students make a silly mistake. They put H, they put as height, which is wrong. Okay, which is wrong. It's not the distance from surface. It's not the distance from surface. You must take the radius of Earth, include the radius of Earth plus the height. Remember, R is always to the center of provider. The distance to the center. In other words, it is the distance to the center of the point mass. Distance of the point to the center of the point mass. Okay? So how to compare between this gravitational force and gravitational field strength? So the difference between gravitational force and gravitational field strength is gravitational force, you must have two mass. Okay, let me rewrite the equations. Let me rewrite the equations here. So what's the difference between gravitational force and gravitational field strength? Gravitational force, you see, it has two masses. It has two masses. It has the point mass. It has both the point mass and the test mass. It has both the point mass and the test mass. Two masses. So for gravitational force to exist, it must have two masses. It must have the point mass and the test mass. If only has one partner, only has a point mass, then if there is no partner, then there's no attractive force. This attractive force won't exist. It won't exist. So if only one partner like this, like this one, only one partner, there's no gravitational force. Who is he pulling? There's no partner for him to pull each other. Okay, so if only one mass, there's no pulling force. There's no pulling force. Who you want to pull? Nobody, isn't it? So pulling force, or the gravitational force, you must have two mass. You must have two mass, only we have gravitational force. Okay, that's why we have 2m, mm, or m1, m2. Okay, however, for gravitational field strength, it only relies on one mass, which is the point mass. Remember, gravitational force relies on two masses, whereas gravitational field strength only need one mass. Only one mass, which is the point mass, the provider of field is enough. You only need the provider of field. The Earth as the provider of the gravitational field. So even there's no test mass over here, the field still exists around the Earth, because Earth is the provider of field. Okay, the point mass is the provider of field. So for gravitational field strength, only has one mass, which is the point mass. But for gravitational force, it needs two masses. It needs the point mass and also the test mass. Okay, understand? So that's the difference between force and field strength. Okay. All right. This gravitational field strength has 2 units. Okay, has 2 units. So talking about gravitational field strength, normally the unit for gravitational field strength we put as Newton per kilogram. Okay, because it is corresponding to the meaning of the formula itself, Newton per kilogram. Gravitational field strength is the gravitational force per unit mass. So Newton per kilogram. But if we use another terms, acceleration due to gravity, this one talk about motion. So we use meter per second square. We use meter per second square. But these two, they are the same thing. They are the same thing. Like force equal to ma. See that? So they have the same, yeah. Because it all go back to the, these are the same. Because last time we learned about what? We learned about F. F equal to ma, isn't it? F equal to ma, and then later on we learn V equal to U plus AT. You see that? F equal to ma, and so in terms of here, this A here has the unit of Newton per kilogram. Okay, Newton per kilogram. But talking about motion here, V equal to U plus AT, we are still using the same symbol A, isn't it? This one we use about motion, we use meter per second square, but they are the same thing. Newton per kilogram or meter per second square, they are the same thing. Okay, they are still referred to the same thing. So that's why gravitational field strength is also called acceleration due to gravity, and they are the same thing. So that's why they have 2 units. Either you can write as Newton per kilogram or meter per second square. Okay, so that's all for this part of video. Thank you.